Hi there! Welcome to our next Geometry Flip class. Be excited because today our session, our sixth session, is entitled Triangles. We're going to learn everything about triangles. Here are the key terms I need you to watch out for. We will learn what are the acute triangles, right triangles, obtuse triangles, equiangular triangles, isosceles triangles, scalene triangles, equilateral triangles, including what are the legs, hypotenuse, the vertex angles, and the base angles. Aside from these terms, I want you also to watch out for what is an altitude, what is a median, what is an angle bisector, the perpendicular bisector, including what is an orthocenter, a centroid, incenter, circumcenter, and the two theorems, the exterior angle theorem and the isosceles triangle theorem. Let's start first with the basic concept of a triangle. Last time, we learned that a triangle is a polygon with three sides, three angles, and three vertices. In this given figure, you can name all of its three sides, and they are side AB, or you could use any other symbol such as gamma. The second one is side AC, or you can label it as beta. And the last side is side BC, or you could use the symbol alpha. Aside from these three sides, you also have three angles here. And the three angles here are angles ABC, angle BAC, and angle BCA. And we also have our three vertices here, denoted as the special points, like point or vertex A. We also have point or vertex B, and point or vertex C. These are the basic parts of a triangle. As a whole, this triangle is named as triangle ABC. Notice that the symbol we used is this small triangle here. Okay, let us first consider the classification of triangles into two groups. The first is we can classify triangles in terms of angles. There are four types of triangles according to angles, and these are the first two. In 20 seconds, I would like you to probably name what are these types of triangles and probably include a short definition. Five seconds left. Time is up. Okay, our first figure here is actually named or labeled as an acute triangle. It is considered as an acute triangle because all of its interior angles are considered to be acute angles. The second figure here is one of the special types of triangles named as right triangle. It is named as a right triangle because one of its interior angle is considered to be a right angle. And this is here, labeled with this small rectangle. Aside from these two, we also have two types of triangles according to their angles. Similarly, in 20 seconds, I would like you to define and probably name these triangles here. Okay, time is up. Now, this third type of triangle according to angles is actually named as an obtuse triangle. Why obtuse? Because one of its interior angle is considered to be an obtuse angle, and this is this colored, yellow colored angle. And the last one is called an equiangular triangle. Equi, same, angular angles. In short, all of its interior angles are considered to be acute and all of them are equal. To denote equality of measurements, we use this symbol here. These are the four types of triangles according to angles. But I would like you to focus on one special type, which is actually considered to be the right triangle. In this figure, the two sides adjacent to the right angle are named as legs, and the side opposite the right angle is called the hypotenuse. It is a special type of triangle because it has many uses later on. Aside from triangles according to angles, we can also classify triangles according to sides. And there are three types of triangles according to sides. With these three figures here, in 20 seconds, I would like you to name them and probably add a definition. You may start. Kindly look at the symbols used as a hint. Okay, time is up. In the first figure, all of its sides are actually equal, and therefore it's called equilateral triangle. Equi, same, lateral, sides. In short, all of the sides are considered to be equal. Again, look at the symbols. The second type of triangle is considered an isosceles triangle, wherein only two sides are considered to be unequal. And the last type of triangle is named as scalene triangle, wherein, as you have noticed, no sides are considered to be equal. These are the three types of triangles according to sides. Now, I would like you to focus to what an isosceles triangle is. Its equal sides are named as legs, and the last one is considered as base. The angle directly opposite the base is called the vertex angle, and the two remaining angles at the bottom are called base angles. This is also a special type of triangle you need to watch out for later on. Aside from the types of triangles, there are also special segments and points in a triangle. Let us start with an altitude. In this given triangle here, our altitude is this line segment drawn. In 20 seconds, please define what an altitude is. Go. Five seconds left. Okay, time is up. In this given figure, altitude is also considered as the height, and it is defined as any line segment drawn from any vertex of a triangle that perpendicular to its opposite side. Aside from this altitude, you can also draw this second altitude here from another vertex and the last one from the other vertex. Take a look at the intersection of these three altitudes. It is considered as a special point, namely an orthocenter. That's an altitude and an orthocenter. Let's talk about the second special segment. Its name is a median. A median is this figure here. Similarly, in 20 seconds, I would like you to define what a median is. Go. The hint of the definition is the symbols drawn at the bottom. Time is up. How did you define a median? Well, that's correct. A median is actually any line segment drawn from a vertex of a triangle to the opposite side to its midpoint of the opposite side. Aside from this, we also have the other two medians from the other vertices connecting to the midpoint of the other two sides. The intersection of these three medians is considered as the center of gravity, or its name is actually centroid. That's for the median and centroid. Our fourth special segment is named as an angle bisector. From the name itself, probably you can already have its definition. And that is this line segment here. In 20 seconds, make use of this figure to define what an angle bisector is. Go. Time is up. Okay, from the name itself, it's very obvious. Angle bisector is any line segment that is actually drawn from a vertex to the opposite side, and it divides or bisects the given angle. Aside from this angle bisector, you can also draw the other two angle bisectors of the other two angles here. The intersection point of the angle bisectors here is also a special point, namely as an in center. That's your angle bisector and in center. We have our last special segment, and probably its corresponding point, the perpendicular bisector. You already know what a bisector is, what perpendicular is, but in 20 seconds, please define this line segment. Go. Okay, time is up. Well, from the name itself again, a perpendicular bisector, probably not from the vertex, but it's just any line segment drawn perpendicular to the midpoint of a side or to the side. These are the three perpendicular bisectors, and its common point is also a special point named to be a circumcenter. So these are the special segments and special points you can see on a triangle. Now let's talk about our next theorem in geometry. Its name is an exterior angle theorem. Take note, it's a theorem, so we need to prove this one. It states that the measurement of an exterior angle of a triangle is equal to the sum of the two interior angles non-adjacent to it. In this figure here, we are going to show it later on if this theorem is true. If I'm going to extend this base, I have here a exterior angle in a yellow colored angle. We need to prove that this yellow colored angle is equal to the sum of the two orange angles there. In 20 seconds, try to have your own proof. Go. Okay, time is up. Again, we need to show that the exterior angle, which is a yellow one, is equal to the sum of the other two interior angles. Take note that the yellow and the blue angles here are forming a linear pair, and they must sum up to 180 degrees. Aside from this fact, we also know that the sum of the interior angles of a triangle, the two orange colored angles and the blue one must sum up to 180 degrees. To prove this further, let us use values here. Let us say that these two orange colored angles are measured to be 70 degrees and 50 degrees. For this triangle to be a triangle, The blue colored angle must be 60 degrees in order for the triangle to have a sum of 180 degrees. If this is true, the yellow colored angle, which is a linear pair of a 60-degree blue colored angle, must also be 120 for it to become supplementary. This is the proof of this theorem because when you add up 70 degrees and 50 degrees, it is just 120 degrees. This is the proof that the sum of the two interior angles non-adjacent to the exterior angle is just equivalent to the exterior angle, 120 degrees for this figure. This is the proof of exterior angle theorem. Aside from the exterior angle theorem, we also have our second theorem, namely Isosceles triangle theorem. It states that the measurement of the two base angles of an isosceles triangle are equal to one another. Let us consider a figure here, and we are going to show if the base angles are equal. Let us say it is an isosceles triangle, therefore the two legs are equal, and the base angles here are this yellow and orange colored angles. We need to show that the yellow and orange colored angles are equal to one another. In 20 seconds, try to make your own proof. So, 5 seconds left. Time is up. Okay, I will show you the proof of this one, but I'm gonna make this one smaller for additional construction. We need to prove that the yellow colored angle is equal to the orange colored angle. We need to prove this one by drawing a reflection of this triangle at the bottom and adding two lines, just like this one, line L and line M. And we need to assume that line L is parallel to line M. If this is true, this yellow colored angle is also the altered interior angle of this, the first given yellow angle. In short, they are equal. If they are equal, using the base as the transversal line, we know already that it's just a reflection, and therefore that is just a reflection of the orange colored angle. This is the proof of the theorem that the measurement of the two base angles on an isosceles triangle are equal to one another. This is the proof of the isosceles triangle theorem. Okay, if you were able to view this video, I would like you to comment the following numbers in the comment section of Schoology. If your names are not listed here, probably it's on the next slide. Reminders to all, you could always review this video, and you could always ask your classmates who understand well, and yours truly for some clarifications. It's very important for me to know if you were able to view this video, because this is actually my anchor on what would be our activity next meeting. Please review this video so that you will learn and be prepared more for our class session. Okay, that ends this session for today. Our next session would be session 7, would be quadrilaterals. Thank you for viewing this video. Hopefully you've learned something, and be prepared for our next class session. Have a nice day, and thank you once more.